So again, happy Thursday, happy Thursday. So are these triangles similar? German, I was about to say, yes, yes. Okay, I do know you, of course. So are these similar, and how do we know? Well, did we learn anything yesterday that may give us a clue? Were there two things that have to be true in order for two figures, two polygons, two shapes to be similar? Does anyone remember? Anybody? Hello, is this thing on? Is my sound off again? Okay, yesterday in our notes, I gave you two criteria for two figures to be similar. What were they? And do these meet those criteria? That's all you have to do, right? I'm asking you if these triangles are similar, and your brain should have said, well, first of all, something should have happened in your brain, right? So you should have had, wait, where is it? Where is it? I think you can actually hear it, right? An alarm should have gone off in your brain saying, oh, we talked about this yesterday. I remember this. And then you go back to your notes and go, there's two things he told us yesterday and we wrote it down. And the two things, but I could barely hear him because his sound sounded different yesterday, right? The two things are all angles are congruent, right? Because if we change the angles, then we change the shape of it, right? If you have a shape and the corners change because their angle gets bigger or smaller, the shape is going to change. So the angles have to stay the same. But the sides are going to change, right? The sides are going to change, but they're going to change proportionally. Proportionally. That means all the sides change at the same rate. And some of you have learned that rate is short for ratio. Some of you didn't know that before this class. You're like, oh, hold on, where is it? Hold on. Right? When I told you that rate is short for ratio, your brains did that. Some of your brains did that, right? Rate is short for ratio. They grow at the same rate. They grow at the same ratio. And if you have the same ratios, that's a proportion. That's why you say things are proportional. Right? When you have a figure, like some of these, have you seen some of these McFarlane figures, like sports ones and stuff? Those are done to scale, right? So it's actually proportional to the actual person that they're doing it after, right? The player, NBA player, NFL player, soccer player, whoever, NHL. But it's proportional, meaning they shrink the person at the same rate, the same ratio, which makes it proportional. So let's look at that. So if you looked at your notes, yes, all corresponding angles, and there should be an S right there, angles are congruent, and all corresponding sides are proportional. They shrink or grow at the same rate. They shrink or grow at the same rate, the same ratio. Okay, so let's see if that's happening here. So if we look here, 40 degrees, 40 degrees. 60 degrees, 60 degrees. 80 degrees, 80 degrees. Right? So we can make a little checklist here. All angles are congruent. Check. Okay, so now we got to check. Sides are proportional. So that means I'm going to make a ratio. I'm going to make a ratio of small triangle to big triangle. So you got to decide what your ratio is going to be. So before you make your ratios, you need to decide what's the ratio going to be. Because I talked about this yesterday. Are we going from small triangle to big triangle? Are we increasing it? Are we zooming in? Or are we going from big triangle to small triangle? Are we zooming out? And so I'm making my ratio where I put small on the top, big on the bottom. Could you have done this? Could you have done this and made a ratio like this? Yeah, you could have done that. I'm choosing not to. Right? I'm choosing not to. I'm making my ratios small over big. So now I'm going to make a ratio of small over big. So here we go. 10 and 30. So I'm going to put 10 and 30. Does that equal, let's look at two other sides. Does that equal 11 and 33? Okay. Are they equal to each other? Well, let's simplify both. What's 10 divided by 30 if I simplify that? That's 1 over 3, right? What's 11 divided by 33 if I simplify that? That's a 1 over 3. That's a 1 to 3 ratio, right? That's a 1 to 3 ratio. They're both the same, so this is proportional. And so I say, yes, the sides are proportional. And there you go. Mister, I did it the other way. I did big over small. Okay, that's fine. If you did big over small, guess what? We still can look here. We can still say, okay, 30, and it matches. We got to match it with the corresponding side. We're not going to put 30 over 9, right? Because you see how this is 40 to 60 degrees? This is 40 to 60 degrees. That means these sides are the matching sides. These sides are the matching sides. And how are you going to know in the future what are the matching sides? They'll tell you, like this will be labeled A, B, C, D, E, F, and then you'll know that A, B is matching with D, E by the order that they give it to you in. So if you want to go big to small, that's fine. Yours just would have been 30 over 10. And does that equal this side compared to that side? Right? We're just comparing 33 to 11. Okay, and that would just be 3 over 1. Does that equal 3 over 1? Yes. Yes, it does. Okay, so that's all we're doing. We're looking to see, are they the same exact shape, just bigger or smaller? That's what similar means. They're the same exact shape, just zoomed in or zoomed out. Okay. All right. Let's go to our notes. So here's what we did yesterday. Now, some of you were like, Mister, I was confused about what we were talking about. I needed to see an example. So I'm going to give you a second. I know we went over this a little quickly, and it's just a warm-up. So if you're still not understanding 1,000,000%, so would it be 3 to 1 or 1 to 3? Yes, the answer is yes. I'm sorry, the answer is it depends. It depends. Which one are you talking about first? It depends on your sentence. Right? You would say a sentence like this. The ratio of big triangle to small triangle is, so big to small, right? If we look here, big is on the top, small is on the bottom, so it's 3 to 1, right? Big on the top, small on the bottom. The order that they say it in matters, is 3 to 1. If you said a different sentence, if you said the ratio of small triangle to big triangle is 1 to 3. I would say the small first, and then I would say the big next, right? It depends on what the sentence you're saying. Okay, this is why you have to explain yourself now. Does that make sense? Okay, so it could be 3 to 1 or 1 to 3, depending on if you're saying big to small or small to big. Depends on the sentence. That's why you have to. Tell me why. Right? You have to explain yourself. You can't just say, oh, it's 3 to 1, 1 to 3. Well, okay, which direction are you going? Okay, so let me give you a second to copy that. I'll give you a minute to copy that. Okay, I don't see a thumbs down, so let's continue. So now, again, let's repeat what we talked about yesterday. What's the definition of similar polygons? Well, similar polygons are what we talked about, zoomed in or zoomed out, the same exact shape, except they're bigger or smaller. It's a bigger version, and it's not distorted. It's an exact version, just smaller, right? And can you tell me where you see that in real life? Can you guys tell me where you see that in real life? Where do you see scaled down versions in real life? Posters, right? Posters. You have a poster. You can have you ever hear of a life-size poster? A life-size poster is a big, huge poster because it's the actual size of the person, right? But when you buy a regular poster, like, let's see, what do I have around here? Hold on. When you have a regular poster, look at this, right? Is the actress who plays Captain Marvel as big as my head in real life? No, she is not. No, she is not. She's an actual human-sized person. But if you look in the poster, you know who it is, right? You know who it is because it's the exact person, but just shrunk. All right, are there any other examples? Like this sticker right here. Kobe Bryant was not this small. Kobe Bryant was not this tiny. But we know it's Kobe because it is the exact shape of Kobe, just proportionally shrunk. Right? All right, is there anything else? This poster's the only thing. Anyone else have any hobbies or anything? Or have anything that where how do you think people build houses? What do you think an architect does? Does anyone know what an architect does? Hello, is this thing on? Hello, hello, hello.
Bueller.
They use blueprints. Yes, what's a blueprint? Right? Have you guys heard of blueprint? You see these people that when you think of an architect, you see they have these big rolled up papers, right? Right? The houses, right? So it's they roll out these big pieces of paper, and it's an overhead view of the house. Now, are the blueprints actual size? Right? Imagine if the blueprint was the actual size of the house, you'd have to have a whole field, a whole empty lot to put them out. No, they scale it down. They scale it down, and they need to know what scale they're doing it at. They scale it down and put it on a piece of paper so you can see it on a desk, a normal sized desk, or maybe a little bit bigger desk, but so that way you can see, okay, well, this beam right here has to be 10 feet. Well, the picture on the blueprints is not actually 10 feet, right? They had to shrink it down, and they shrink everything down at the same rate, the same ratio. They call this the scale factor. The number that they use to shrink or expand something is called your scale factor. So if we looked at here, what's our scale factor? Now, our scale factor depends on what order you're going in. Are you going from big to small or small to big? Okay, so that always matters. Did you hear me? Order matters, right? Because we could have two different answers, 3 to 1 or 1 to 3 for a warm-up. So if I ask you, what's the scale factor of the big triangle to the small triangle? You'd say, oh, it's a 3 to 1 scale factor, or a scale factor of 3, right? Because you would say this as a fraction, right? You wouldn't say it you could say it like this, but we mostly say it like this, 3 over 1, which is just 3. So you'd say, oh, it has a scale factor of 3. Over here, you'd say, oh, it has a scale factor of 1 to 3, or you can say 1/3, right? The scale factor is 1/3, meaning the small triangle was 1/3 the size of the big triangle. Does that make sense? Okay, so let's do a problem. So scale factor. Right here it says scale factor, and look at what it says right underneath it. Look what it says right underneath it, what I keep repeating, right? Order matters. Order matters. So if we look here, what is the scale factor of ABC to DEF? Now, they give us two triangles and they give us an order. You see how they give us an order? So that means AB matches with DE. They're not congruent, but they match. They correspond. BC matches with EF. And AC matches with DF. Okay, so now we know which sides match. So I'm going to look at AB and DE. So here's AB and DE. Okay, so which triangle comes first? Which triangle comes first? Well, which one was said first? Which one was said first? ABC, right? ABC was said first. So I'm going to put 8 first. Over, which one was said second? Well, the other one, right? And that's 12. So 8 to 12, can I simplify that? What's 8 over 12 if I simplify? How can I simplify 8 over 12? 1 to 3. 1 to 3? Really? Well, how do I simplify 8 over 12? What can I divide 8 and 12 by? 4, right? So divide this by 4. Divide this by 4, and I get 2 over 3. Okay, let's try another one. Let's try BC, right? What does BC match with? BC matches with EF. So BC, which is 10, over EF, which is 15. Right, let's simplify that. What's 10 over 15? I can divide by 5. So what do I get? I get 2/3 again. Yes. All right, let's try the last side. Just to make sure. So that to that, 14 to 21. So what can I divide 14 and 21 by? By 7, right? So divide by 7. So guess what I get? 2/3. So look at the ratio I get for comparing all three sides. I get the same ratio. So guess what that is? That's my scale factor. This is 2/3 the size of this. So how do you find your scale factor? You just make your ratio. So how do you find your scale factor? Make ratio of sides. That's it. So my scale factor here is 2/3. Okay. And how do I know it's 2/3? Because what is the triangle they said first? In this question right here, let me erase it. In this question right here, what's the triangle they said first? They said the ABC triangle, so that's the one that goes on top. And then second, they said DEF, so that's what goes in the bottom. The first one they mentioned always goes first or at the top. The second one they mentioned goes on the bottom. So now look at this next question. This next question is saying, what's the scale factor of DEF to ABC? Well, wouldn't I just flip it? Right? I get the same ratios. They just would be, I'd put the big triangle on the top and the small triangle on the bottom. So guess what this would be? Anybody? What over what? Now if I switch them, if I say what is the scale factor of DEF, big triangle, to ABC, the small triangle, exactly. It's 3 over 2. Right? Now we just flipped them. Now we have the big triangle on the top. And so we're going to say this triangle is 3/2 bigger than that. Well, 3/2 is basically 1.5. So we're just saying this is 1.5 times bigger than this one. Okay, that's what that means. And then the last question, what is the ratio of the perimeters? Big to small. So again, you can call the triangles or whatever the figures are, you can call them big to small. So that's what I like to do. I like to say, are we going from big to small or small to big? Because that's how this works. That's how this works. You always have a bigger figure and a smaller figure. So are we going from big to small or small to big? Well, they want to look at the perimeter of big to small, right? So my ratio will be big to small. And what does that equal? Well, what's the perimeter of this one? What's the perimeter of the small one? And what's the perimeter of the big one? Well, just add them up. Perimeter just means add them up, right? So add up. What's 14 plus 10? 24. And 24 plus 8? 25, 26, 27, 28, 29, 30, 31, 32. So the perimeter of this small one is 32. And what's the perimeter of the big one? Well, let's see. 21 and 15 is 36. And 36 and 12 is 46, 47, 48. So what's the ratio? Now, what do you think the ratio is going to be? What should the ratio be? Well, let's see. We have the perimeter of the big triangle is 48 over the perimeter of the small triangle, which is 32. And if I simplify that, what can I divide 48 and 32 by? What can I divide 48 and 32 by? What number can I divide 48 and 32 by? 16. Yep, 16. Very good. So if I divide by 16, 48 divided by 16 is 3. 32 divided by 16 is 2. Guess what? Guess what? It's the same ratio. It's the same ratio. And we're not surprised because we said that over here. Their perimeters are also proportional. Okay? So that's just a little proof that their perimeters are also proportional. Okay? So scale factor is just that ratio to go from one triangle to the other, the lengths of the sides. And how do you find that scale factor? Make a fraction of those lengths of the sides and make sure the top one is the first one you say and the bottom one is the second one you say. And that's it. That's how you find a scale factor. And this scale factor here for these two triangles was either 2 to 3, small to big, or 3 to 2, big to small, depending on how you say it, depending on the order they ask you. Okay, are there any questions? I don't know if you noticed this, and I keep reminding you of this, but some of you keep ignoring me. I'm going super slow. You see that? I only went on this second box now. Yesterday we did that top box. We spent an entire period talking about that top box. Today we just talked about scale factor, and we talked about it slowly, and the warm-up was kind of about it, was an intro to it, and then we talked about it, we looked at it, we talked about the different order. Are there any questions? Because I'm going slowly so you understand this. I don't know if you noticed that, but I'm going super slow to make sure you understand this. And some of you, yes, it is easier. Ratios are so easy. I don't know why so many students think they're so difficult. You're just comparing two things. And in this case, you're comparing the sides, right? Big to small, small to big. If it's blurry for you, I'm sorry. I'm trying to zoom in as much as I can. But again, if it's blurry for you, you can go watch the video later. I'll put it in the Schoology, or you can just go straight to the YouTube channel and look for your Period 11 video. And go ahead and hit that like button. That helps my algorithm. So if there's no questions, we're done for the day. Okay, the homework isn't up. We're gonna do more notes tomorrow. We will continue talking about similarity statements, because once they have a scale factor like this, once they match like this, we can say they're similar. And we can start making similarity statements and then checking if two figures are similar. Then we'll have some classwork and homework. So I'll put that up. I'll put that up tomorrow, okay? And then the homework will probably be due on Monday. Since I'm going to assign it tomorrow, the homework will be due on Monday. And the classwork we'll work on tomorrow and Monday. Does that sound good? I'm trying to spread this out as much as possible so you understand this better. Right? Because I know some kids get confused with ratios and proportions. All right, if there's no questions, guys, take care. Have a great Thursday. Go get those exclusive Funko Pops from the ECCC Virtual Spring Conference.